All right. I'm Alex. You might know me as A-North on GitHub and Slack and things like that. And yeah, for anyone, for those who haven't met before, I've been working on Filecoin since before mainnet, working on protocol design and development, improving Filecoin to be faster, better, cheaper, a better version of our MVP. You're going to hear from me a few times today. Some of them will be short, some of them will be slightly longer. This first one's one of the longer ones, but it'll set the stage for some shorter sessions later on. And so yeah, as framing for the directional kind of things I want to talk about today, let me briefly start with why, I guess. From Filecoin's mission, I've plucked out a couple of the key words that tend to be the focus of my work. So all parts of the Filecoin mission are important, but the words efficient and foundation are sort of the two parts that my work is most directed towards. We need an efficient platform for storage, an efficient system in order for it to be useful, in order for it to compete with and be a viable alternative to other types of systems. And I'm particularly focused on it being a foundation, so a platform for other people to build things upon. The other parts of the mission are decentralized. I'm taking for granted here everything here is within the constraints of decentralized. That's sort of already significantly the case, and I only aim to preserve it. But my real focus here is on the platform for building storage-related things and the efficiency of that platform. Can we go next slide, please? Wait, how do I click? There we go. So just briefly, as sort of some more framing here, the lens, the direction I'm taking for understanding Filecoin and the directions for improvement are in how useful Filecoin can be to the rest of the world, to Web3, to data owners, to data clients, people who want to work with data. What value can Filecoin provide to them? If one thinks of it as a business, what value can Filecoin, the network, provide? And then, of course, capture some part of that in order to remain a sustainable business. But my goal is to make Filecoin useful and have the economics sort of follow from that. So efficiency obviously matters a lot here. That the more efficient the underlying service, the lower the costs are for providing this value to the world, the more the potential there is for sustainable economics underneath it. Okay, so useful storage. So let me be clear here. When I'm talking about useful storage, this term can mean two different things. The useful storage I'm talking about here is the storage capacity being useful to provide a service. The storage capacity being a useful primitive upon which to build a service. So by useful storage here, I mean the storage capacity that can be used. I'm not talking at all about the what particular data is going in there. That's another meaning of useful storage, which other sessions will talk about. But I'm talking about the flexibility of sectors to store data. What functionality does Filecoin offer to put data into sectors, to read that data out of sectors, to change the data in sectors, and so. This storage is sort of, I see, the fundamental utility, the fundamental value that Filecoin offers. There are other things, of course, that Filecoin, the network, offers other kinds of value. I'm not meaning to exclude those, but it's the one that I'm focused on is the utility of storage. I think it's worth thinking briefly about this, the distinction between storage as a service that can be offered, as a function that can be offered to users, from the physical reality of that. Of how that service is instantiated. It's useful to think of the distinction between on a PC, the distinction between a hard drive, a hard disk, and the sort of low-level driver software that goes with that, and a file system. As an application developer, you interact with a file system and you write these abstractions called files, and you can read and write files and seek around them and so on. Many of you will know there's extremely little correlation between the abstract view of a file and how that data is laid out on a physical storage medium. You might see a file as like a linear sequence of bytes, and in fact they're scattered in various chunks all around the hard disk, and some of them are duplicated, and some of them, some sectors of the drive go bad, and the data gets moved transparently underneath, and all of that is completely abstracted from you, just storing a file and reading it back again later on. The useful service that the file system offers is this storage of data and reading it back again. And users of that service are usually highly abstracted from how that service is actually realized. And so there's a similar distinction to be made in Filecoin, I believe, between the utility of store some data, and in Filecoin's placing it with a particular storage provider and under particular terms, from which sector that data is stored in, for example. The Filecoin use of the word sector is directly inspired by the use of sector in hard disks as being like a physical unit of storage. Users of a file system don't know what sector their data is stored in. And to some extent, I think the same kind of abstraction can serve Filecoin well to make it easier to offer the service of storing data without necessarily exposing clients to exactly what sector it is in, and without necessarily locking that down. Okay, so useful storage. Where are we? Useful storage. So basic storage, the basic utility of a storage service is that you can put data into it, you can read it back out again, and you can change it, replace it, update data. This is the basic utility of storage that I think Filecoin should provide some of it today, and we want to work towards all of it. We have a unique environment though. This decentralization aspect is an overriding assumption and constraint on how we can do things and what we can do things. And so if you imagine for a moment hypothetical changes to the Filecoin network where storage providers could at will put data into and out of sectors without, with no restrictions, that would not form a good application platform, because people who use such a platform in this decentralized world need to know somehow that when a provider tells them that they've stored some data in a sector, that they can't go and overwrite that data the next day and put someone else's data in there and not tell you. The data needs to be persistent. And so unrestricted reading and writing of data into sectors by SPs would not be sufficiently, it's not a sufficient platform for someone to build a useful storage application on top. In fact, this utility of reading and writing and updating data, that's the utility that storage providers provide. That's the utility that someone with the hardware provides. The utility that the Filecoin network can provide is constraints on that free read and write that can be relied upon by applications and by clients. And so the utility that the Filecoin network really provides is this ability for a storage provider to make a commitment to storing data for a particular time and mediating those commitments so that applications can be built on this commitment to store data for some unit of time. And so I have a thesis here that that the efficient foundation for storing data is a service that provides free reading and writing update of free mutation of data in sectors, but with enforced commitments to what can and cannot be written into a sector. So, for example, the important service is that a storage provider can put data into a sector, and the network can prevent them from taking that data from overwriting that data for some unit of time that the SP is committed to upfront. Now we have that today. It's just not. We don't have the first line. We have the enforced commitments, but we don't have the ability to update data in a sector later on. So, all right. So that's all sort of set up. A bunch of my brief talks today will focus on bits of this thesis or bits of this system. This is I'm aiming at the simplest system that can do these things. Once with this primitive of an enforced commitment, I believe most of the I believe a lot of higher level, directly useful to clients and users functionality can be built. But I think this is sort of these are the primitives that would let us do that. Okay, so I want to briefly talk about some of the near-term work on that. Many of you know I've been working on a proposal called Direct Data Onboarding, which is FIP 76, which goes a long way towards closing the gap between where we are today and where I think we should be. So by analogy, I'm going to sort of I'm going to describe these situations as a conversation between a storage provider and a market. A market, in today, it's the built-in market actor. It's acting as it's an agent for a user or a client in doing a deal. So today, the conversation goes something like, and these are all sort of on-chain messages that happen today in order to put data into a sector. Firstly, the storage provider indicates to the market an intention to put data into a sector, and the market says, okay, but also says if you don't now follow through on that, you're going to be busted and pay a fee. Then the SP says, can I please commit data to this sector? And the market says yes. But if the market says no, the SP can no longer do it. Now this has to be the same data, right? These D have to be the same. And if the D are the same and not too much time has elapsed, then the market will say yes. Otherwise, it will say no. And the SP will pay a fee. And then finally, the SP says, I really did commit the data until epoch data D. And then the market says, okay. But the market can also say not okay if it was, for example, too late. And so we have these three steps of the conversation. Sort of the mandatory way, the only way for an SP to write any data into a sector. So a couple of things that I think are problematic with this. One is it's very inefficient. So there's these three discussions that need to take place before that actually happens. And two, the built-in market actor has these multiple points where it can say no, and when it says no, the SP pays a fee. And so this is a thing that is possible for the built-in market actor as a trusted piece of code within the system that the Filecoin developers write, as opposed to someone building a smart contract in a VM. So no one else can write a market that says no and causes the SP to get penalised in the same way. And we want, in order for many different kinds of deals to be made with different features, different lengths, different sizes, different scales. I very much believe we want a platform for many people to be able to write many different market applications. And market is even just a narrow set of the type of data-related applications that could be built. So you can replace the word market with data DAO or archive or bounty contract or anything like that. These are all the applications that could be built. Market is just the one that we have today. And so the built-in market here has this privileged spot today, where it's the only way to be allowed to put any data into a sector is to ask the market, and the market can say no. The market only has one way of expressing the terms of a deal. Okay, so what should this be? Here's what I think it should look like. Is the SP puts data into a sector and then tells the market, hey, I put data into a sector. It is now up to the market or the storage application or the data DAO or whatever to decide, to acknowledge that, hey, if you put data D into a sector until epoch E, then that satisfies this deal, which you arranged previously. The etc. here in this line hides hides arbitrary information that the SP can provide, can transmit to the market at the same time. And so, for example, one thing we will be able to achieve soon, not right after FIP76, but one iteration later, is what I might call instant deals, where off-chain the client and provider can make negotiate deal terms, the deal proposal that we know today. I get that signed by the client, and then in a single shot message, the SP can commit data to a sector, transmit the signed deal proposal to the market, satisfy that deal immediately, and have the deal activate. So your one message to immediately activate a deal. And again, deal here is the specific thing that the built-in market does, but broaden this to any kind of data application that wants to know about data being committed into a sector. And the market can acknowledge this, but it can't deny it. It can't say, the market here has no power to say you're not allowed to commit this sector because you didn't clear this data with me previously. The market scope is constrained to, like, does this satisfy a deal I know about? If so, great. If not, I don't care. All right. So into the near term, so what I described, the FIP76 doesn't quite get as good as that single shot conversation that I mentioned. The built-in market actor would require more refactoring to get to that single shot deal. Right after FIP76, if you want to use the built-in market, you're going to have to publish a deal first and then satisfy it. But future changes could get us to that one-shot thing. If you don't want to use the built-in market, then the built-in market will no longer have a privilege to say, no, you can't commit data. And I didn't mention verified data at all, but all of this works with verified data. No essential changes to how that works. Next steps to this. After FIP76, the dynamics has changed where the SP puts data into a sector and informs a market about that commitment. Doesn't ask permission, it just informs the market. The next step is to allow the miner to inform any on-chain contract about the commitment instead of only being allowed to inform the built-in market. This is a relatively easy and obvious next step. There are just some security issues we need to work through, invoking untrusted user programmed code with these notifications as part of the sector onboarding workflow that we don't need to worry about when we're only using the built-in market because we trust the code. So as soon as we work out how to call untrusted code from these network critical operations with appropriate safeguards so that a malicious market can't grief a miner and a malicious miner can't grief a market, as soon as we sort of put bounds on that, we'll be able to allow any smart contract to be notified about data commitments, and that allows anyone to implement a market which might have different terms. Any markets can then do deals that are larger than sectors, they can do deals that are longer than sectors, anything they can build on this primitive of a commitment to store data for X, until epoch E. So a long deal can be constructed by chaining commitments one after the other. You can do an infinite length deal that way. A large deal can be many commitments aggregated together into one sort of market concept. Another step after that, I'll talk more about updatable sectors in a subsequent talk, actually possibly the immediate next one. But being able to replace data in a sector. So currently, when a SP commits data into a sector, that data in that sector are coupled, they live together. The SP has no ability to change the data in the sector until the sector expires or is terminated and it disappears. So there's no resnap. There's no like, I've done this deal, but now I want to use this capacity for a new deal. Not a thing we can do today, but will be possible soon. Moving and deleting data. So I mentioned the true service that a market or a user wants is a commitment to store this data. SPs will have more flexible operations if they can continue to satisfy that obligation to store data, but move it between sectors over time. This is another way to get long deals. Is like, I commit to store this data for 10 years, but I'm going to have to move it to different sectors over time to meet that. Deleting data, but here I don't mean just the ability to delete data. I actually mean the ability to prove that a miner deleted the data. And so it'll be possible for future markets to express, store this data until here and prove that you have no longer storing this data after that. Now that proof is limited, right? It's limited to prove that you're not storing it in the same sector where you proved it was previously. And we can't stop someone storing a backup offsite, putting on tape. I'm not suggesting we can do that, but we can prove that that the data has been removed from where it was previously stored. Okay, and then sort of the features that Juan talked about yesterday that we want about large deals, long deals. These are things that are application level concepts that can be built on top of this primitive of a commitment to store data until epoch E. There's the simple thing that we can get the built-in actors to express. All right, that's my pitch. I wasn't tracking time, but I think I'm ahead of time. I'm going to stop there. Yeah, we've got heaps of time for questions and discussion. Otherwise, I think I'm also on next, and so